Okay, we're gonna do another video for Math 115, and today we're gonna do probability assignment 2. I'm gonna go over it, though we were going over some of it in class. This is just for my own records, and hopefully if you haven't finished this will help. On top of that, it's basically the same thing for the new assignment that we got, so I'm not gonna go detailed into this. I'm gonna let you just go ahead and take a look at the answers and figure this out. If there is a 60% chance, this is question 1, right? If there is a 60% chance of rain on Saturday and a 70% chance of rain on Sunday, then there is a 130% chance of rain over the weekend. Select all that apply. Well, we select the chance of rain over the weekend should be 100% because rain is always possible. At any time it could rain. Number 2, there is not enough information given to calculate the chance of rain over the weekend. And then number 3, chance is never greater than 100. Okay. So then we got part B, the probability that a baseball player hits a home run is greater than the probability that he gets a successful hit. Well, in order to get a home run, you have to have the successful hit first. So a home run, by definition, is a successful hit. So the probability that he gets a successful hit must be greater than or at least equal to the probability that he hits a home run. Okay, next one. There's this graph. It shows the emotional health index. I won't read it, but we'll go down to the question. It says, now this is part, is this C? No, number 2, question 2. Find the probability that an emotional health index score is 82.7. Round your answers to 4 decimal places, which I swear before it said fraction, so I have mine as a fraction. But let's see, 82.7, we look at 82. Okay, this is an 82, but this is definitely not going to be near 7. This would be more closer to the 7 because it's closer to the 83, right? So we got these two. And so we know it's 2 out of how many? And then we have to count all of these different ones to see how many there are. I'm just going to show you my paper just so that you can see I counted each bar, and there's 14, right? So that's why I did 2 out of 14. Now technically, if he's saying we have to do a decimal, then we would take 2 and we would divide it by 14, and that would be 0.142, and then we round this, so it'd be 1429 for mine. Okay, so that's basically what you would be doing on for this one. It says find the probability that an emotional health index score is 81.0, and if we go to 81 here, it would have to be on the line to be 81.0, and there's nothing. There's not one of them that hits that line. So the probability is there's not a single chance, 0 out of 14. If you were to divide that, you could get your decimal, right? All right, then what occupation has the highest emotional health index? Since this way is going the emotional health index and this one is the occupation, we look at which one has the highest. That's this one. It's physician. Okay, let's move on. So we got physician for that one. Okay, we're on question 5. This is where it gets really tricky, right? So we're going to find the probability of C. C here is the registered voters who support same-sex marriage. So how many are there in this statement here? A field poll survey reported that 69% of registered voters in a state approved of allowing 2 people of the same gender to marry and have regular marriage laws applied to them. So registered voters who support same-sex marriage, this is 69% approved of it. So 69%, you move the decimal to take it from a percentage to a decimal, you take a decimal at the end of that and you move it over 2 times, which would make it 0.69. Find the probability of B. B is the registered voters who say the Supreme Court's ruling about constitutionality of the proposition is very or somewhat important to them. So as we read on, it says among 18 to 39-year-olds, registered voters in this state, the approval rating was 74%. Now that's just of the 18 to 39-year-olds. But 5 in 10, for me it's 5, it might be something else for yours. 5 in 10 registered owners in this state said that the upcoming Supreme Court's ruling about the constitutionality of a proposition was either very or somewhat important to them. So that's what we're looking at, 5 and 10. Okay, so that's 5 over 10, and if you were to break that down in fractions, you know that's 1/2. Or basically we got 5 over 10 equals, and when you divide that 10, the 5 by the 10, you get 0.50, or be 50%, but we need the decimals, 2 decimals. So we need 2 decimals, so we got 0.50. Sorry, let me get that to zoom in. 0.50. Okay, next one, we have the probability of C given A. Registered voters who support same-sex marriage, given that registered voters are 18 to 19 years old. Well, we read that. The 18 to 19-year-old registered voters in the state, the approval rating was 74%. So, again, turning that into a decimal, we got 0.74. The probability of B given C. What's the probability that the registered voters, basically, who say the Supreme Court's ruling about the constitutionality of the proposition is very or somewhat important to them, given that they are registered voters who support same-sex marriage? Well, that last line here, 79%. Well, okay, out of the registered voters who support same-sex marriage, which is basically what we just read, 79% say the ruling is important to them. Okay, so we know that's 79%. So we turn that to a decimal, 2 places, 0.79. This is part E. In words, what is C given A? Registered voters who support same-sex marriage from the group of registered voters who are 18 to 39 years old. In words, what is B given C? Registered voters who say the ruling about the constitutionality of the proposition is very or somewhat important to them from the group of registered voters who support same-sex marriage. Part G. Find C and B. Okay, so this is where it's going to get complicated. We are not given C and B. And, okay, let me find my pen. Where did that pen go? Hold on. Okay, so what they're asking for, again, let me get zoomed in. Okay. Okay, if we were to write the formula, right, what they're looking for is P, and it says C and B. Okay. So we don't know what this is. If we were to just do the formula, right, we would think it would be C times B, but that doesn't work. That doesn't work in this situation. We need to find out what is C and B. So we're gonna go. Let's see. We have to do the C given B, and then we would have to do. So we have to do that formula to be able to find what this is. I mean, if I were to write it out correctly, it'd be like that, but, right, probability, everything's a probability, and probability, so sorry, it's so hard to write like this. Okay, so that's the formula that we'd be using to find out what this is, because we know what this is, and we know what that is. So, let's go back up. C given B. Okay, let me get my notes out. Okay, so this would be, if I were to write it outright. We don't know what C given B is, but we do know what B given C is. So let me switch that around. Let's just use that, because this is going to be the same no matter how we switched it. B given C. So even if I switch that, let's see. B given C. We'll just switch these now. Okay. Just going from the information that we do know. Let's go with that. Okay. Because we're just finding out what C and B is. This is not going to change whether it says C and B or B and C. This is going to make a difference, though. We need to go off of the information that we do have to be able to get that. So B given C, what do we have? We have 0.79 equals, we still don't know this, B and C. But we do know what C is. What is C? C on mine is 0.69. Okay. Now, thinking algebra, just imagine that that B and C is basically x over 0.69 equals 0.79. Okay, and when you see that in algebra, and you want to get that one letter all by itself, you have to do the opposite of whatever it is doing. So this, to get the letter by itself, we would have to do the opposite of division, which is multiplication is the opposite. So we would times both sides, right, by 69. This would cancel this out, and then we'd have to times 0.69 times 0.79. Let me get my calculator that I cannot see right now. 0.69 times 0.79 equals 0.5451. Okay, 5451. Okay, let's bring that back. Okay, so if I did that, right, if I did this 0.69 on this and 0.69 on that, right, then this would come out to 0.5451 equals the probability of B and C. So we have to do all of that work just to get that. Like I said, it doesn't matter that it says B and C, because basically it's timesing those two together, and as long as they're in that parentheses, it's going to be the same answer. So 0.5451 is the answer. Okay, so let's move on. Can you erase that? Okay. Okay, so moving on. In words, what is C and B? It is registered voters who support same-sex marriage and who say the Supreme Court's ruling about the constitutionality of the proposition is very or somewhat important to them. That would be the correct answer. Okay, now find C or B. Okay, what is the formula for finding the probability of C or B? We know that the formula would be the probability of C plus the probability of B. Mommy? Oh, hold on. No. Minus the probability of C and B, right? Okay, so now let's go get our numbers. What are our numbers for C? RC. Okay, hold on. Okay, so the probability of C, my C is 0.69. Okay, 0.69 plus what is B? B is 0.50 for me. Minus C and B, and that's the one we just did. In fact, a lot of times you can't do the or until you've got the and. So my C and B in part G, right? C and B is 0.5451. 5451. So I always do these two together, and if there's others, I do those two together. But so mine, when I do 0.69 plus 0.150, comes out to 1.19. Then minus 0.5451. And then when I do that on the calculator, 1.19 minus 0.5451 comes out to 0.64449. When I bring those two down, it's going to be 0.6449. Okay, so when I write this, basically, because I don't leave it there, you would go, right, probability of C or B equals that. So this is the right answer right there. Okay, so I put that in. Okay, move this down. Right there, 0.6449. That's for part I. Part J, which is the last part for this, and then I'm gonna stop the video and I'm just gonna do it in increments of time because this is 15 minutes already, so we're not gonna continue. Are C and B mutually exclusive events? Explain why or why not. No, because C and B is not equal to 0. If it was mutually exclusive and you put the two of them together, if they times by each other, they would equal 0 if it's mutually exclusive, right? And we know that it's 0.5451. Cannot be mutually exclusive. Okay, so they are somewhat dependent on each other. So that's it for the first 5 questions, and then I'll start the next video starting from 6.